Welcome, developers. Today, we're diving into a crucial skill for building robust AI systems, unit testing. We're going to implement comprehensive unit testing for our AI quiz platform's core services. This isn't just about finding bugs, it's about building bulletproof software. You'll learn how to write tests that catch issues before they ever reach production. Master the art of mocking external dependencies, like complex AI APIs, and understand how to achieve that critical 80% code coverage, the gold standard that differentiates amateur code from truly production-ready systems. Why does this matter so much in AI? Traditional web apps might just show wrong data if they fail, but AI systems can make wrong decisions with real-world consequences. Think of unit tests as your essential safety net, designed to catch those tricky edge cases before they escalate into user-facing disasters. For instance, when giant platforms like ChatGPT handle millions of requests daily, rigorous unit tests are what guarantee each service component behaves predictably under countless conditions. Your own quiz platform needs that exact same level of reliability to truly scale and succeed. Let's get started on making your AI systems incredibly robust. So, how do we structure these tests for maximum efficiency and impact? Our testing architecture is built on the proven test pyramid principle. This means we have a broad base of fast, isolated unit tests, fewer integration tests in the middle, and just a handful of essential end-to-end tests at the very top. This layered approach allows us to isolate our business logic from external dependencies. We achieve this by replacing those external systems, like AI APIs or databases, with mocks, predictable stand-ins that return controlled responses. This isolation is key. It lets you test complex scenarios without worrying about network latency, API rate limits, or non-deterministic behavior that can plague real external services. For our test framework, we'll be using PyTest. It's incredibly powerful with its flexible fixture system and excellent assertion introspection, making test writing feel natural and eliminating much of the boilerplate you might find in other frameworks. Finally, we'll leverage coverage analysis to measure how much of your code is actually executed by your tests. Aiming for 80% coverage means your tests are running through 4 out of every 5 lines of code, a widely accepted industry standard for high-quality production systems. Now, let's get into the practical side, the specific patterns for testing your services effectively. First, we focus on business logic testing. This involves testing the core logic of your quiz generation independently. Imagine testing how your system adjusts quiz difficulty based on a user's performance history. You'd arrange a given performance, act by generating a new quiz, and then assert that the difficulty correctly matches the user's capability. Next, we tackle AI integration testing. This is where mocking becomes indispensable. You'll mock the AI API responses to simulate various scenarios. For example, you can test your system's fallback behavior when the AI service is unavailable, ensuring a graceful degradation instead of a crash. And finally, data validation testing is crucial. This ensures that all your input sanitization and validation mechanisms are working perfectly. You'll test edge cases, malformed data, and even potential security concerns to make sure your system is resilient against unexpected or malicious inputs. These patterns ensure every critical part of your service is rigorously examined. To keep our tests organized and effective, we follow the universally recognized arrange, act, assert, or AAA pattern. First, you arrange your test, set up any necessary test data, and configure your mocks. Then you act, execute the specific function or piece of code you're trying to test, and finally, you assert. Verify that the outcome matches your expected results. Our implementation workflow begins with Phase 1, Service Layer Testing. Start by testing your pure business logic, functions that transform data without side effects. These tests are incredibly fast and catch a high percentage of bugs. In Phase 2, integration points, you'll test how your services interact with external systems still using mocks. Here, your focus shifts to robust error handling and complex edge cases. Finally, coverage optimization involves using those coverage reports to identify any untested code paths, prioritize adding tests for critical business logic over less vital utility functions. And our quality gates ensure continuous excellence. Your entire test suite should run in under 30 seconds for rapid feedback, automatically catch regressions, provide clear failure messages, and consistently maintain 80% or more coverage on your core services. These gates are non-negotiable for production readiness. This commitment to comprehensive unit testing isn't just academic. It's how leading companies build reliable, scalable systems. Giants like Netflix, for instance, run millions of unit tests before deploying code. Your quiz platform, by adopting these same professional practices, will ensure remarkable reliability as you scale from 100 to potentially hundreds of thousands of users. Now, for your assignment challenge, I want you to implement unit tests for a brand new feature, adaptive quiz difficulty. This system should dynamically adjust question complexity based on user performance patterns. Your tests must cover the performance calculation logic, the difficulty adjustment algorithms, and all those tricky edge cases like new users or perfect scores, along with AI API failure scenarios. To approach this, start with the core algorithm, mocking the AI service for various responses, and test edge cases like an empty performance history. Use parameterized tests for efficiency across multiple difficulty levels. And crucially, implement performance benchmarks to ensure your tests remain fast. Remember, good tests do more than just catch bugs. They tell a clear, concise story about what your code should do, serving as invaluable documentation for future developers, including your future self. Happy testing!